So this session is going to be a little bit, we are going to go over some things that we haven't already seen related with soil, but I'm going to introduce a new thing that is called JADAM. We're going to talk about JADAM a lot today, and JADAM has a set of principles with which you can elaborate products yourself, and I think that you are going to enjoy that. So I thought that for the last class, it is pretty advanced. I will say this is pretty advanced, but I wanted to finish with this type of class
on a high note.
Yeah. We have talked about this before. Like I have talked in several classes about this. For me, a healthy soil means that you have healthy plants. So it is very important. And you can do, and you have seen that in the supermarket, you have fertilizers for tomatoes and all of this. But if your soil is already healthy, it means that you don't need to continuously supplement your plants. Maybe if you have them in pots, because a pot is more like a closed environment. But if you have a garden, if your soil is healthy, your plants are going to grow healthy. They are going to have less pests. So yeah, this class is around having a healthy soil, because I truly believe that then you're going to have healthy plants. We talk about this as well in the first classes, I think, but I just wanted to remind you a little bit. When we talk about soil for gardening, we are mostly talking about these first two layers, or in soil they are called horizons. So what we call topsoil normally is these first two layers. The first layer is mainly organic matter, and here we can find organic matter in different stages of decomposition. So some of it will be very fresh. For instance, if one leaf of a plant or a lettuce has fallen into the ground, so that will be super fresh, and then it starts to degrade until it is humus. Humus is the most stable organic matter when it has already been decomposed. And then the layer under the organic matter is going to be the mineral matter, and it's more minerals and materials that come from the underneath layers. Now, if we take like a little piece of our of soil, imagine that we have the ideal soil, the perfect soil, and we take a little piece. So we are going to analyze which proportions we can find there. And this is mostly divided into two: the solid portion, that is the pieces that are physical, let's say, that constitute our soil physically, and the space, that is the little spaces that are within the soil. So if we start analyzing the physical part, we have about 45 to 47% of inorganic minerals that basically comes from this rock that is underneath and is broken down and constitutes the soil. And then we have between a 2 and 10% of organic matter that comes from the things that fall from above the soil into the soil. And this organic matter, even if the percentage is very small, is very important because it's the one who retains the water, so very important for our soil, and it is where the nutrients are. And these nutrients are going to be the food for our plants. So even if the proportion of organic matter is small, it's very, very important for our soil, and especially for our garden soil, because we need our plants to feed on this organic matter. Now, in the space portion, so in the spaces that are between the particles of our soil, we can find a 25% of air. And this is very important because the roots and the plants and the animals that live in the soil, they need air. So when you have a soil that is very compacted, for instance, where you have like cars passing through all the time, or you see when there is a path in a park and people walk over, you can find few plants, and one of the reasons is because we are compacting the soil, there is not enough air, and plants have difficulties to grow there. So this is for you to realize how important air is inside.
I find that is a problem in my lawn, actually.
Possibly.
The lawn doesn't have enough air.
It's one of the reasons. Also, lawn has other type of problems. If you want, we talk about it later. But yeah, lawn has several problems apart from that.
Because I have to scrape it to leave a bit of air.
We can talk about it later. You can do some things with it. Yeah, I will tell you some ideas later. Yeah.
Thank you.
And then the other quarter of the soil composition is water. And in both the spaces of air and the spaces of water, you can find soil microorganisms and the roots of the plants. And this is about 15% of the soil. Hope this makes sense. So this is like if we were analyzing an ideal soil, the percentage that we would like to find. Now, in the organic matter of the soil, that is the first layer that we have talked in our garden soil, we can find, as I have said, organic matter in the composition, so from very fresh till very decomposed. And then we have humus. Humus is the stable state of the organic matter when it has been decomposed, digested, and everything, and then it's going to stay as it is in the soil. This is called humus. And this process from organic matter in decomposition to humus is made by soil microorganisms. Not only microorganisms, but also earthworms, fungi. Well, fungi can be a microorganism, but yeah, it's the key. Soil microorganisms are very, very important, are key in this process. And why this is important? Why these soil microorganisms are important in this process? Yeah, they are the ones who decompose organic matter into humus, and that means that there is a cycle of nutrients. So when, for instance, when a leaf from the lettuce of Martin falls into the ground, if we want this leaf to become a nutrient so the next lettuce can grow, you need microorganisms to be decomposing that leaf. These nutrients going into the soil and be made available for the next lettuce to grow. So if you don't have microorganisms doing this for you, you basically don't have this cycle of nutrients. And your soil is basically dead. You are extracting the nutrients and putting it into your plants, but the nutrients are not coming back to the soil. This is a big problem with agriculture nowadays, with this extensive agriculture, because the nutrients are not coming back to the soil. They need to use fertilizers, especially chemical fertilizers, because this natural nutrient cycle is broken. And one of the reasons is because they don't have soil microorganisms, because they are doing barbarities with the soil. The microorganisms, have to say, because they are decomposing the organic matter, they made nutrients that are very important for the plants available for them, like nitrogen, phosphorus, and other micro and macronutrients that are very important. So if you don't have microorganisms doing this for you, you need to add them, like with the chemical fertilizers. They also fixate the carbon into the soil. So this leaf of lettuce, it is made mostly of carbon and water. The microorganisms, by acting on it and by decomposing the leaf and converting it into humus, it means that leaf is becoming part of the soil. So the carbon that was before on a leaf, that before was on the air, now is fixated in the soil. And you can imagine that this with climate change is very important. This is why we need to plant trees as well, and all of this to fixate the carbon into the soil. Yeah, sorry, and that's it. So these are one of the reasons why having a good, healthy population of microorganisms is important in our soil, for our soils.
So what would you do with big things like the peas, when the peas are finished? Will you cut that also and leave it in the soil there?
So it depends. For instance, here in UK we have the problem of slugs. So slugs feed on this organic matter in the composition as well. So me, what I do, When it is hot, like from now on, when it's hot, if I pull a weed, I leave it on the ground because now it's hot and it's going to decompose, if you see what I mean. But if it is more like in a spring or in autumn, I put it in my compost bin, because if I know that I leave everything on the ground, the slugs are going to get attracted to it.
Yeah.
You see what I mean? But for instance, as we have talked before, when I cut the plants, I leave the roots inside, because the roots are going to decompose and they are already underground, so it's perfect. It's like a very free way of contributing with organic matter to the soil. Yeah. And then what I do is when my compost is decomposed, then I put another layer. But I will tell you today about another way you can do this.
Right. Thank you.
Because these guys, the guys of JADAM and the Korean natural farming, they have another way of doing things. That's why I wanted to talk about this today. So JADAM is one modality or one way of doing organic agriculture and organic farming, because it also has methods to apply on animals. And this was developed by one guy that is Korean, and then another guy developed another method that is very similar, that is Korean natural farming. So I'm going to be mostly talking about JADAM. I'm going to say a couple of things about Korean natural farming, but everything is kind of the same. They work a lot with microorganisms, with things that you can make yourself. So it's very related. But yeah, just to let you know that if you want to search for it later on after the class, you can search for JADAM or for Korean natural farming, for both terms.
Was that the video that you put through?
Yeah, so the video, I'm going to link these ones in the YouTube video as well, so you can investigate a little bit of both. That video was about JADAM. It was the author of JADAM. Yeah. And JADAM is a method of doing ultra low cost organic agriculture. So this guy made up these methods because he realized that organic agriculture, or the understanding that people had of organic agriculture, was using products that are very expensive in the market and things like this. And he realized, like, we can do the things by ourselves, like our fertilizers, our liquids to enrich the soil in a very low cost way. He was thinking about what is the name? People that are working their own ground and maybe they don't have means to go to university, or they don't have means to do a lot of research or anything like this. So he wanted to provide them easy and cheap tools so they can transform their land in organic agriculture without spending a lot of money. So I thought it was a fantastic idea, and we can adapt it to our little gardens as well. Like, why we need to be buying a fertilizer from Tesco when we can do it on our garden, and it's even better. And we are not wasting plastic in the plastic bottle. So why not? So that was my idea as well. This guy, what JADAM means is something like people who are like nature. What this guy did, and he's a scientist, is he tried to observe the process that happen in nature and try to mimic them in organic agriculture. So it is very, very interesting. And he focused a lot in soil microorganisms, because for them it's the same. If the soil is healthy, the plants are going to be healthy as well. So I thought that it was very interesting to talk about this in the last class. It has a series of principles that are very simple. I'm going to put you an example later on. They are very simple. He tries to simplify the way of understanding this. They are easy to make. You will see he uses the residues of the crops, water, leaf mold, things like this. So it's very, very affordable and very easy to make. It is very scientific. This person made a lot of tests, and if you see his book and if you see his videos, you will see he made tests, trying different products, trying different proportions. So when he developed a formula and he recommended you a recipe, is because he has tested it extensively. It's not like he just tried and that's it. Or he's suggesting something. He has tried, it has worked, and he has perfected it, and then he's recommending the recipes. So I like that. I like that he's very scientific. And yeah, it is effective because it has been tested and is very low cost. So these things make this method very, very nice in my opinion. This is an example of a land that has been treated with this method. So this is how it looks. You see it is covered in this white, and then if you see it closer, these white things, they are mycorrhiza that are like the kind of the roots of fungi, and this enriches the soil because this fungi associates with the roots of other plants and help them to acquire nutrients. So as you can see, you normally don't see a land like this white. So it is a different approach. It's a completely different approach from normal agriculture. Now I want to show you one example of the principles that rule JADAM. For instance, about fertilizers. He thinks that in nature there are 3 rules about fertilizers. And we are understanding fertilizers here as leaves and other things that fall into the ground. So the 3 rules that this person saw in nature is that the fertilizers are fresh. So our idea of adding organic matter to the soil now is like you need to put compost that is already dry and already decomposed, like almost like humus, and then you put that in the soil. But he saw that actually when a tree releases the leaves fall fresh into the soil. You see what I mean? The organic matter arrives fresh. So he's thinking why we need to decompose and put compost that is already decomposed and ready if nature put the things fresh on the ground. So this was his thinking, like he couldn't understand this. Then this fresh organic matter, the leaves of the trees and all of this, they fall into the soil surface. Sometimes in modern agriculture, what people do is that they put the fertilizers inside of the soil, but he thought the leaves fall on top of the soil, so why we need to do anything inside of the soil? Doesn't make sense. Nature doesn't do it. And the other thing is that the fertilizers are applied in autumn because it's when the leaves in the temperate regions like UK, when the leaves fall in autumn. So he's thinking why we need to add fertilizer in spring or in summer. It's not natural. The natural thing is that the leaf fall in autumn. Do you understand? So he was analyzing nature in this way, and he was trying to develop his methods around what he saw in nature. And I find this very, very interesting. So this is only one example with fertilizers. Now, what this person did is develop a series of products that he called them inputs, and that they are developed in very simple ways, and we are going to see some of them. And he put them these names, like GLF stands for JADAM liquid fertilizer, then you have GHS, that is JADAM hair solution, and you have fertilizers, you have pesticides, you have many. And we're not going to talk about all of them, we're going to talk about some of them. And then once you make these ones that are like the basic ones, then you can combine them between them. So for instance, the pesticide is made combining 2 of them. This kind of things. You can see here that is the combination of 3 of them that are there. So you do like the basic ones, and then from those ones you create other products. You are going to understand it now when I explain more. So, for instance, he believes that the soil needs to be built before you put the plants. So he will start to apply products in autumn. So in spring, when you plant your plants in the garden, the soil is already built. And I find this very, very reasonable. Very, very reasonable. So why you need to start to build the soil in the spring when your plants are already on the soil? If you give them a good foundation, the roots are going to be much happier, and then the plant is going to grow much stronger from the very beginning. So how he builds the soil? There is one part in green and there is two parts in black, if you see. So the guy of JADAM, he uses indigenous microorganism solution and liquid fertilizer, and with this he starts to build the soil in autumn, so in spring is ready. Now, Korean natural farming, there is another person that uses another method that is called indigenous microorganisms. It's called IMO. So it's another type of product that he also put it during the autumn, and it can be combined with these two. Actually, they can be combined together. So yeah, if you are interested in building your soil with microorganisms, you can have a look at these three things, starting in autumn, and in spring the soil will be ready. And we are going to see how to make some of these solutions later on. Then he has a watering method as well. What he does is irrigation to water the roots, and a foliar spray, because the leaves also benefit from receiving microorganisms because they are going to be better able to defend themselves from other pests. It's very interesting. So he does the irrigation and a foliar spray with this GMS, and he mixes it also with seawater, because seawater has a lot of minerals that are like micronutrients for the soil and for the plants. And then with a solution of elite, that is a kind of a rock that you can skip that if you don't have it. But this is a watering method that he will use throughout the season. So before putting the plants in autumn, he will start to build the soil, and then once he has put the plants, he will water always during the season using this method. And then after the crop has passed and he has collected the crop and it is ready, imagine that you have stems or leaves. But what these guys do, instead of chopping it and removing it and putting in a compost bin to decompose it, they leave the residues on top of the soil. They leave them there. They use this indigenous microorganism solution to spray it on top, so the microorganisms start to act on this residue and to decompose it on top of the soil, and they will cover it from the sun to keep the moisture and the humidity, and this will create a layer of organic matter that it will stay on the soil. So instead of putting compost already made, they leave the residue from the previous year. This is Martin, you were asking me. So in this case, they will chop the peas, the plant of the pea, and they will leave it on the ground. They will spray the solution, they will cover it from the sun, and the soil will be ready for next year. So it's another approach. It's a very different approach. And in their opinion, and I agree, this follows more what nature does.
And the cover from the sun, would they actually use a cloth or some sort? Or
Yeah, like a blanket. Yeah.
Yeah, right.
Because then they stop the sun from over drying it. Because if you are spraying a solution that is liquid, you need some humidity for these things to act. Yeah. So it makes a lot of sense. And then what they develop is a fertilizer program that is very interesting. I'm just going to show you like very quickly. So they have a base fertilizer. In this case, it's like wild grass cover crop plus the crop residue that you have from your garden, plus manure that can be cow manure or horse manure that you can find locally. And then you can use different types of fertilizers that are the ones that are there in different dilutions, and they have different recipes from different fertilizers that we can see now. So this is what they will do. Now I want to talk about some inputs. So these guys, as I have shown you before, they have a very long list of different things that you can make. I just want to explain you some of them so you understand the whole idea, and you understand also how difficult or how easy they are to make, and then you can decide what you do. If you prefer going for fertilizers and other products that you can find in Tesco or in garden centers, or if you prefer going for things made by yourself at home. I totally understand that some people don't have a garden, and you cannot have something fermenting very pestilent in your kitchen in London. I totally understand that. So I know that this is not for everyone, but for the ones that we have some space, it can be a good choice. So the principles when making these kind of inputs that are liquids, fertilizers and pesticides that we apply in our garden is that they use anaerobic processes. Anaerobic means that the microorganisms that are going to be doing this, like acting inside of these inputs, they don't use oxygen. Aerobic means that these microorganisms will be using oxygen. So yeah, these processes, they don't need oxygen. So very often you can put a lid, you can close it because it's anaerobic. It doesn't need oxygen to occur. To start the processes and to give like some initial food to the microorganisms, you simply use water and leaf mold. Leaf mold is you go to a woodland and you take this first layer of leaf that are on the ground. You cannot just go to a road and take the leaves because these leaves are polluted and all of this. So it will be better to go to a park or a woodland or somewhere clean and take this first layer, and that will be your leaf mold. And that is full of microorganisms. It has the organic matter of the own leaves, so it is a very good way of starting to make these products. And they use this instead of sugar and molasses. In organic agriculture, sugar and molasses are very, very often used to start, to give like a start to these microorganisms, but they are very expensive. So this is why in JADAM they use water and leaf mold, some things that you can easily acquire instead of paying for sugar and molasses. In natural Korean farming, they use more sugar and molasses.
And the leaf, what kind of leaf? Any leaf? Or?
Yeah, any leaf. You know, when they start to rot a little bit and they are like soft, this is perfect.
Even tree leaves then?
Yeah, even tree leaves. Yeah. For instance, the oak forests, they are super fertile and super nice. So if you can find an oak forest or an oak woodland somewhere, that is perfect. Yeah. You can even make it yourself. Like if you have some leaves in your garden, you can gather the leaves somewhere, leave them to rot a little bit and to decompose, and then you can use that yourself. You know, with what I did some of the things as well with manure, because with horse manure, because it was how to say, I don't know if you have ever looked with attention to horse manure, but they don't digest that much, so it doesn't look like poo. It's very, you can see the pieces of vegetables. So I used that as a starter as well, because I can imagine that it was full of microorganisms and a lot of veggies. So I just used that and it worked actually. Yeah. So it's more flexible than we think. These products are done using ambient temperature. In most cases, I will tell you a couple of things that where you need heat, but in most cases it's ambient temperature, and that's good because it doesn't have an added cost. You don't need to use heaters or anything. And for JADAM, even if you can modify the fertilizer a little bit, and I'm going to show you some examples later on, you can perfectly use the same fertilizer during all the growing period. We talked this at the beginning, that at the beginning a plant uses more nitrogen, then when then the plant is more starts to reproduce, it needs more phosphorus. If you want to increase the size of the fruits, normally you need to add more potassium, and then to have the fruits to ripen, like if you want a tomato to get ripen quicker, you can add calcium. But these guys, they are not changing the fertilizer continuously according to the stage of the plant. They tend to use the same fertilizer more or less diluted across the season, because they are more focusing again on the microorganisms of the ground than in the plant itself. But we're going to see a couple of examples where you can tune it as well. So this will be our first input or our first product. It is called JMW, and it is done simply with leaf mold. That it looks like that. You put it inside of a little bag, and you hang it in the water. And the water is better if it is rainwater because it has less impurities. And then these guys, they put some rocks on the bottom because the rocks release minerals into the water, so it's an added benefit. And if you want to use this as it is, for 1 square meter of your garden, you will put 1.2 liters of this solution. And I gave you there an example of how you can calculate that. Like, you can put 0.021 liters of the solution in 1 liter 1/18 of water. And you can dilute the solution from 100 to 300 times. So this is more, it is flexible. It's not that there is like only one recipe for the dilution. The garden is going to be happy anyway. The second input is called GMS. And this one is basically the same. You put in one basket, in one of these hanging bags, the leaf mold, and on the other one you put boiled potatoes. And the water is the same. It's rainwater, and you can put the stones at the bottom if you want. And in this case, the leaf mold is going to release the microorganisms into the water, and the potatoes are going to feed these microorganisms. So it's like one step further from this one. This is focusing more in microorganisms. Here you are giving some food to the microorganisms, if it makes sense. So you are enriching the solution even more. And one recipe, it is here: 10 liters of rainwater, 10 grams of sea salt, so you are adding some mineral, 10 grams of leaf mold, so you are giving a start to the so you are adding microorganisms, then 20 grams of boiled potatoes, 20 grams of your crop residues of your own garden. And he add the crop residues, because they think that then you are adding the microorganisms that you already have in the garden, and this is good, instead of bringing external microorganisms. So you are promoting your own microorganisms, and I think that this makes sense as well. So he puts all of this together, then he closes the lid, he leaves it under the sun for 3 days, and then when you see this bubbly, you see the bubbles, it means that it's fermenting, so it is ready to use. And then for 1 square meter of garden, you can put between 0.02 and 0.05 liters. And you can use this for irrigating, so directly to put it into the ground, or you can make a foliar spray. As we have said, it is good for the leaves as well to have a little bit of this solution, because then they say that they are more resistant to pests as well. And also, it's like our skin. Plants absorb products as well through the leaves. Our skin is the same, so you are giving them a little boost as well. I don't know if you have heard, but they say the same. If you spray seaweed and other things, you are promoting growth. So it's kind of the same idea as well. So we have two at the moment. This one only leaf mold. This one with the leaf mold and potatoes. And this is how the recipe looks like in the book. It's one of the books that I put in your bundle. It's a very big book. It's more than 300 pages. So I will leave it here. I have you can see that sometimes the recipes are done for very big amounts, because this method is developed for people that have very big land. So what I have done is, like, I have cut it down to make a little bit for our little gardens, but you can scale it up or down as you feel to, just keeping the same proportions. And you can see in YouTube there are videos to watch where they show you step by step how they do it and how it looks like. I'm going to put the link to the YouTube video when I upload this one, so you can easily find them in case you want to do any of these recipes. So you can watch it slow, like with a lot of attention.
And 500 liters is actually for the garden, as much as that.
Yeah, but think that they are doing this for very big lands. When they are producing like wheat, and you see what I mean, when they are producing commercially, it's a method that is developed for people that are producing crops commercially.
You would reduce it to how many liters for the garden?
So it depends on your garden. So that's why I say here that for 1 square meter of the garden is this amount.
Ah, right, okay.
Yeah. And for this one, yeah, this I did it because of that. Yeah, because we have small gardens. So, and then you can see, I don't know, maybe you have 10 square meters, so you need 12.2 liters. You can then move it. You have 5 square meters, then you multiply this by 5. Yeah. Yeah, I try to make it easier, so I put here the same. I did it with all of them, so you can have it, Martin. You can calculate it for your garden.
Thank you.
For me, it's the same. It's small. Now, the third product, the third input, is the liquid fertilizer. So, in this case, you have a pot, like the one that we see down, and you will fill it with the residues from your garden, so the leaves of the peas that you have finished and all of this, or even with the food waste from your house, like banana peels or whatever. And then you fill it with rainwater in a proportion of 1:1, so the same amount of water than residues. Then you will put a handful of the leaf mould that we talked before, and then they say that you can enrich that with 1 kg of this stone that is called fillet or fruit peel for the smell, but you can skip that. And then you leave it under the sun, and that's it. That will be your liquid fertilizer. If 1 square meter needs 4 liters, and that is an example. But this is flexible. You can dilute it from 330 to 500 times. So it's very, very flexible. They recommend applying this from early to mid growth because it's very rich in nitrogen. So it's good to give them a boost at the beginning. And they recommend it putting it in the soil or putting also as a foliar application. So you will put it in a spray and you will spray it on the leaves. It promotes growth, but it can take very long time to make it. So this is here is in the pictures how it can look like at the end. So you can see it has mold and many other things going on because all the microorganisms are growing. But that will depend on the temperature. If it is hot, probably the process goes quicker. If it is too hot, probably the microorganisms die. So you have to keep an eye. So the idea is that this becomes this. Okay, so this
and it says here it takes 6 months approximately to make.
It can take up to 6 months, yeah. It depends. Imagine it here in UK is very cold in winter. So maybe it can take 6 months, or it may not even happen because it's too cold outside. But maybe in summer it can happen in I don't know, 3 weeks maybe, because it's warm. So it depends on the temperature. The microorganisms are happy with I guess from 20 to 30 something degrees, they will be the happier. If it's minus 10, probably they are very like dormant. Yeah. The best is watching videos to see how is the process and how it needs to look like at the end. So when you prepare it yourself, you know how it should look like. That's why I'm going to put links to the videos. So if you're interested in doing one of these, you can watch the video and you know what to expect. Yeah. It's like a recipe, like a cooking a recipe. You need to know what you are expecting at the end.
It's going the other way, it's going the other way from good to what looks bad but is good for the plants.
Yeah, exactly, because
and the soil.
Yeah, because these microorganisms are decomposing the plant. So yeah, but we need to know how it needs to look like at the end. to know when to stop the process. Otherwise, we can have this there in a bucket forever. So it's good to know. Yeah. Okay. Now this will be the fourth one, but it is very similar to the previous one. So this one is richer in potassium. And potassium, it is, as we have said before, is good if you want larger fruit size. Fruit meaning also tomatoes and everything. Like if you have a fruit and you want to make it bigger, you can enrich it with this potassium liquid fertilizer. And I will leave a YouTube video of this one as well, so you can see how is the process. And in this case, you will fill the bucket with wood ash and with rainwater, because the wood ash is very rich in potassium. You will put 10 grams of wood ash in 1 liter of water, and again the same, 1 handful of leaf mould. And in about 15 days, in this case, you have it ready. Every 2-3 days, they recommend it to mix it with a stick. So this is quicker. 1 square meter is 4 liters. They recommend it to dilute it 130, but you can dilute it from 50 to 500 times. And yeah, it is more for mid to late growth. There's a message. I wouldn't recommend you. Susan says they look like good vegetable soup. You can give it a try. The guy, it was very funny. The person developing this method, he thinks like, well, he tried it on themselves. Like some of these liquids, because they have microorganisms, they think that is very good for cattle. You know, cattle, especially cows, well, all the herbivores, they have microorganisms inside that they are helping them to digest vegetables. So by doing this, if you give them this to drink, it's like if you are giving them probiotics and prebiotics that are going to favor the microorganisms. So they give them for drinking. And then some of the pesticides that we are going to see later on, some of the pesticides are good against fungal infections. So they say that for people that have, like, you know, what is the name, athlete foot and other fungal infections in the foot, they can put the feet inside because it's going to stop the fungal infection. So yeah, but I don't know if I will drink it in a soup. But yeah, they have other applications. These liquids have other applications. So yeah, this will be for later on, a little bit later on in the growth of the plant, when they are fruiting and you want bigger fruits, versus the previous ones that were more when you want to promote the growth. But yeah, you can do this during all the period actually. Now, this input, I chose it to show to you because it's a little bit more complicated than the previous one. It's a natural pesticide. So the previous ones were fertilizers. This one is a pesticide. It is called JNP, so JADAM natural pesticide, and it's composed of other 3 products, that is JWA, JS, and JHS. So these 3 together do this natural pesticide. So you need to produce these 3 separately and then mix them together to do the pesticide. And each of them is going to contribute with a different thing. Well, I'm going to talk about these 3 different ones. The first one is JWA, and this is very interesting, and I thought that it makes a lot of sense. It's a wetting agent. So a wetting agent, what they do is, like, the droplets, when you are spraying, they break down the droplets even more, and that means that when you are spraying this pesticide on your plants, you are coating the leaves better. Because if the droplets are very big, it means that you have less droplets in a surface, so you are not covering the whole plant, so it's making it less inefficient. As an example, they had these 2 pictures. The first one, you can see that the drops are very big, and the second one, when they use this wetting agent, you can see that the droplets are much smaller, so they are covering better the surface, and that will cover better the surface of a leaf. So this was very interesting. This is the ingredients. For 5 liters, they do water with potash, and I want to stress this: water and potash. This is like making soap. It's very similar. It's the same process as making soap. This reaction is exothermic. It means that it releases heat, and it is also corrosive. Potash. So if this falls into your skin, it's going to make a hole in your skin. Not a hole, but it's going to be corrode a little bit. So you're going to feel the sting, and of course it cannot fall into your eyes. So for doing this pesticide, you actually need to be careful. You need to put goggles. You need to put them. When I make soap myself, I put the gloves in the kitchen, that the gloves of gum that are the gum. I don't know what is the name. Yeah, I think it's gum. The gloves that they are used to clean the dishes, so you are very well protected and it cannot fall into you. So of course, before doing any of this, you need to watch the YouTube videos, read the recipe very well. But yeah, when you see this mixed with water, you need to be very careful. So in this recipe, they mix these two things together. When the solution is transparent, they use canola oil, and then they mix it with a mixer, an electric mixer, until it looks like mayonnaise. So then you have your solution done. Then they wait 3 days. They add 1 liter more of water. They mix. They add 3 liters more of water, and they mix again. And then the solution is finished. And this is only one component of the pesticide mix. So in the pesticide mix, they will put 0.03 to 0.05 liters of this one for every 5 liters of pesticide. So as you can see, there is a margin. It's not exact science. There's a little bit of margin. But yeah. So you will do this to produce 5 liters, and you will take just a little bit of this for the pesticide. I hope it makes sense. So now we move to the next one. That is JS, and this is sulfur. So this is when we're actually starting to make the pesticide. So the previous one was a wetting agent to make better droplets when we are spraying the plants. This one has already pesticide properties. It will be good to avoid powdery mildew, downy mildew, and fungus. These are fungus as well. So it's more for fungal infections. I think that this is the one where he uses in his food as well, when he had athlete foot fungal infection. If you want to see what is the powdery mildew, you can. I talk about it in one of the talks as well. So yeah, this sulfur, the GAs, will be giving these properties to the pesticide. And how this is made? For 5 liters that you want to produce, you will mix 1 kg of sulfur, 1 kg of NaOH plus 2 liters of water. And again, this will react in the same way than in the previous case. It's exothermic, it will release heat, and it can damage your skin, your eyes. So when you are doing this mix, it's like the same way that when you are doing soap, you need to be very careful. Then, after mixing these things together, you will add 1.6 liters of water. You will wait 2 days, and then in the bucket, you will have like layers of this liquid. And apparently, you need to use only the upper part, because some part of it will sediment, will fall into the ground of the bucket. You don't need to use this. You only need to use the upper parts. And they were saying that you can use this liquid as it is. So imagine that you have powdery mildew. You can use this liquid as it is, but they recommend using it only when you have the disease already. So you wouldn't use it before you get the disease. Only when it has broken out, and not continuously. Like you spray it, you wait for some time to see if it has an effect and everything, and then you spray it again. Because sulfur is a strong chemical. It's not something that will benefit the plant just to have it in the leaves. So you use it only when you need it. And to use in the pesticide mix, you see here that you only need a little bit. So it's like 5 ml for 5 liters of pesticide. So it's very strong. So now we have talked about the wetting agent, we have talked about the second component that is the sulfur, and now we have the third one. The third one is called herb solution, HS, herb solution. And they say that this is good for cabbage white butterfly caterpillars. I don't know, I think that none of you are going to grow cabbage or broccoli or any of these, but these butterflies are a very big problem. The caterpillars can eat leaves in so fast. Like from one day to another you have like several leaves less or full of holes. It's terrible. It's very, very terrible. It's also good for the beet armyworm, for the stink bugs that are curcubitae. They have like a little trump. They're funny. And for thrips. These thrips, they are a small one, very small, like whitish or yellowish, and they are basically on the back of the leaves. I have them in my greenhouse. It's not a very big problem, but I guess it depends how bad is the infestation. So this solution will be specifically for these things. So if you combine it with the previous one that was more for the fungal infections, it makes like a very well-rounded pesticide. And how to make this one? It is very interesting. You can use different plants that are especially toxic for these insects, and they suggest different plants that you can use. One is Jerusalem artichoke. I was very happy to see that because I have Jerusalem artichoke. I don't know if you have heard about it, but when you eat it, you have terrible gases. Really, really, really terrible. I don't recommend you eating Jerusalem artichoke at all. And me, I was very smart, and last year I decided to buy it, and I ate it, and then I regretted it a lot. But now I have a use for the artichoke, so I'm very happy. So probably I'm going to use it.
It's interesting to hear that because beside the tomatoes in France, one of the things I do miss actually are the Jerusalem artichokes.
Really?
We used to eat a lot of them. We had so many that in the end, normally you eat the leaves. And at the end of the season, everybody discard the leaves and just eat the heart. It's in the southwest of France. It's a vegetable that you find in every garden.
Really?
So that's interesting to see. Maybe that's why people eat it outside rather than indoors.
maybe, but yeah, it's terrible. Apparently, when you ferment it, it loses those properties. Like it doesn't give you gases. So I was thinking about fermenting it because it was really terrible.
It's interesting because I never had problems like that. I wouldn't recommend baked beans, but Jerusalem artichokes, I don't remember that.
Yeah.
In the southwest of France, because of the weather, it grows extremely well. And as I said, at the end of the season, they even discard the leaves. But in this country, they're very expensive, actually.
Well, if you want, I can give you, Martin, because I have. So if you want, I can send you some. For this pesticide, they use the leaves actually, so you don't need to. So it's perfect because then you won't then need to discard them, and apparently it's very very effective. So
I'm really impressed. I never thought that would have a good use after you finished with it.
Yeah, right. It's a very interesting method. So, but there are other plants, also the ginkgo biloba, foxglove, tobacco leaves, oleander, Isnerium oleander in Spain and in the Mediterranean is very common. They also use it as ornamental plant. Here in UK it's not that common. But bracken, for instance, is the fern. It's very, very common in UK. Garlic, hot pepper, peppermint. So you can use an array of plants. It's very interesting. Then you mix 5 liters of water for 1 kg of the plant. You boil for 5 hours. So this is one of the methods that requires heat. Then you filter it, and that's it. You have it done. It's not difficult to do at all. And in the pesticide, you will need to mix 0.003 to 0.2 liters for every 5 liters of pesticide. Let's see what Susan says. You see? Yeah. Susan had the same problem. It was terrible. It was terrible. Yeah, so as you can see, this one is very easy to do. The previous ones, they have this reaction that is a little bit dangerous if you are not careful, but this one is very easy to do. So then what you will do is combine the three of them together, and as every pesticide, what you want, think about a pesticide that you are spraying on the leaves. What you want is to stay on the leaf as long as possible. So it makes sense to apply it when it's humid and cool. For instance, imagine that it has been raining during the day, and then it has stopped raining, and it's the night, so you don't have a strong heat or a strong sun. Then I will apply it then, because um, because if it is humid and cool, the droplets of the pesticide is going to stay longer in the leaves. If you apply it on the middle of the day, it's going to stay like 2 seconds. It's not going to be effective. So you need to apply it on a moment on the day when it's going to stay longer on the leaves. And then they have this schema. Sorry that is a bit blurry, but you can see that there you can do different mixes. So it's a range of everything. It's not exact science. So you can do different combinations. So, I guess that this concentration, it will depend on how big is the infestation, or as always, and as I have always say, I really recommend you always starting with a low concentration and to put it in some plants, see how it goes, and then maybe increasing the concentration and spread it in other plants when you see that the plants are reacting good. Yeah, always trying a little bit first, a low concentration, and then move to more plants and bigger concentrations. And this is the end of the natural pesticide. Now, I wanted to show you this as well. This is Korean natural farming, KNF, the ones that I mentioned at the beginning. This was developed by another guy that is called Hankyu Cho. And this one, they made more emphasis to using different products depending on the life stage of the plants. For instance, here you can see, here in plant chemical composition, vegetative, formation of the body. Like when they are releasing plants at the very beginning, they need more nitrogen. When they are starting to go to fruit, they need more phosphorus, more to do the roots, to do the roots. When they are ripening the fruit, they need more potassium and more calcium. So these guys, they change the fertilizer that they use according to the stage of the plant. And then you can see here they have different ones. They have many different ones. I have to say that I have used these ones as well. I especially like the IMO, indigenous microorganisms, and this is the one that I mentioned at the beginning that you can make in combination with the methods that I have explained before. This is to produce lactic acid bacteria and to add them to your garden. I have also this one that is diluted seawater, and this is simply to add micronutrients and minerals to the garden, so it is good. And I have done this one as well, water soluble calcium. I don't know if you remember, but when I talk about the tomatoes, I talk about the tomato bottom end rot, and one of the reasons that why this happened, they say that is because the tomato plant doesn't have enough calcium. So because I was worried about this, I made this last product, but then I realized that I was not watering consistently enough. So think that these products, these inputs, they can help your garden, but they are not going to solve all your problems if you are doing other things wrong. Yeah. So think about them like as an addition to other care, garden care. They are not going to save your life. They are not miracles. Miracles don't exist in gardening. And that's it. This is the end. I know it was a lot of information today. It's just to give you a taste of what JADAM and Korean natural farming can do. Of course, if you need to do any of this, you will need to watch videos where people explain it. I pass you books. I pass you the book of JADAM. in PDF, so you need to read about it. And then when you are very sure that what you are doing and you are taking all the precautionary measures, especially if you are using potash or something that can be that can damage you, then you do it. And if you have any question, you can ask me as well, because I do soap and these kind of things, and I have used these ingredients already. So if you need any help, I can help.
Thank you very much.
And then, yeah, I just wanted to, both of you have signed up. But the 12th, I'm going to give a free workshop on natural beauty and how to avoid chemicals. And I was thinking that if all of you want, we can, the 26th of June, so in some 4 weeks, I think, we can do a small, yeah, like only on a chat online if we want to talk. Yeah, exactly, just to catch up. Oh, all my tomatoes have died. I don't know why. Things like that. SOS, I need help. It can be half an hour. Just have a tea all together and that's it. Doesn't need to be very long.